Welcome back, infrastructure admins. In today's explainer, we are diving deep into a topic you absolutely have to nail down for your certification, NCP-MCI 7.5-15.1 Storage QoS for VM. Whether you're running baseline AOS 7.5, AHV 11.0, or PC 7.5, knowing exactly how to cap or prioritize an individual virtual machine's IOPS is just, well, it's absolutely critical. We're going to break down exactly how you stop a noisy VM from completely starving out the rest of your environment and how to make sure your storage controllers are actually distributing resources based on your strict business requirements. We're going to take this at a nice steady pace so you can really internalize the mechanics under the hood. Let's get right into it. Here is our game plan for today. First, we'll cover why Storage QoS matters, then a walkthrough and core examples. After that, we'll look at some common exam traps, and finally, wrap up with the key facts you need to memorize. Section 1. Why Storage QoS matters, or, as I like to call it, taming the noisy neighbor. Before we get too deep into the weeds here, let's just make sure we're on the same page about why these metrics are so vital. IOPS, which stands for input/output operations per second, is simply the number of discrete read or write requests your storage layer can handle in a single second. Now, in modern infrastructure, we all know compute and memory are rarely the real bottlenecks anymore, right? It's almost always storage, throughput, and IOPS. And that is exactly where Storage QoS, or quality of service, steps in. It gives you, the admin, this incredibly granular control knob. Instead of having to treat a whole cluster or container as one giant entity, it lets you strictly limit these IOPS for one specific VM. That means you get consistent, completely predictable performance for all your workloads, straight across the board. You know, think of a noisy neighbor VM kind of like someone blasting heavy metal at 2 a.m. in a crowded apartment building. The whole building suffers. If you leave a VM completely uncapped, say a rogue VM running this massive database indexing job, it's going to overutilize system resources. It literally monopolizes the cluster's storage controllers, and that starves out all your other critical applications that are just desperately trying to get their own read and write requests processed. But the moment we apply a capped IOPS limit, it's like a real game changer. That VM instantly transforms into a well-behaved citizen. The maximum IOPS the storage layer even tries to admit from that specific VM is sustained over a period of time, and its applications are just straight up not allowed to exceed that level. It fundamentally protects your overall cluster performance, bringing peace and quiet back to the rest of your environment. Moving on to Section 2, Walkthrough and Core Examples. Configuring the limits. Okay, so how do we actually do this? You'll want to build some serious muscle memory for this exact path for the exam. First, log into Prism Central. From the application switcher, you hit Infrastructure, go to Compute, and then VMs. That brings up your list of VMs across all your registered clusters. You just select the checkbox for your target VM, go up to the Actions drop-down menu, and hit Set QoS Attributes. You can also just click on the VM itself to look at its details, and find that same Set QoS Attributes option under the More drop-down. And honestly, the best part about this, it is totally non-disruptive. You can slap these limits on while the VM is powered up and actively serving data. It is a super agile tool when you suddenly get an unexpected infrastructure spike. All right, listen up, because this right here is the secret decoder ring for the exam. If you want to know exactly how Nutanix translates your QoS configuration into actual storage throughput, it all comes down to this one number, 32K. It doesn't matter what block size the guest operating system thinks it's using. Behind the scenes, Nutanix uses a fixed underlying block size calculation of exactly 32 kilobytes. This fixed 32K block size is the absolute dictator of the relationship between the IOPS limit you punch in and the throughput the application actually experiences in the real world. Just to recap, throughput is the actual volume of data your app sees from the storage layer per second. If you don't lock this 32K constant into your brain, the throughput math on the exam is going to seem completely random. So let's actually do the math together with a couple of concrete examples so you can see this 32K rule in action. Let's look at the first scenario. You go in and set a throttle limit of 800 IOPS on a VM. Now let's say the application on that VM is writing data in little 8 kilobyte blocks. Since 8K is well under our 32K fixed limit, Nutanix is totally fine with it and allows the full 800 IOPS. To figure out the throughput, we just multiply those 800 operations by 8 kilobytes. That gives us 6,400 kilobytes per second, which perfectly translates over to 6.25 megabytes per second of throughput. Pretty straightforward, right? But now, look at the second scenario. We keep that same throttle limit of 800, but this time the app is hungry. It's pushing IOPS with a chunky 64 kilobyte block size. Here's where the magic happens.
Because 64K is exactly double our 32K fixed block calculation, each one of those I/O operations basically counts as 2. Nutanix automatically divides your set limit by 2, so the application actually only gets to see 400 IOPS. To find the throughput this time, we multiply those 400 operations by the 64 kilobyte block size, giving us 25,600 kilobytes per second, or exactly 25 megabytes per second. Seriously, make sure you understand this division and multiplication logic. It's practically guaranteed to show up.
Now, when you are actually monitoring your cluster, a really interesting operational reality pops up when it comes to latency. When you set a maximum IOPS limit on a VM, you're probably going to see higher latency pop up on your monitoring dashboards. But, and this is a huge but, it's only for that specific throttled VM. Think about it. The system is artificially holding back those I/O requests to honor your limit, so that single machine builds up a queue which shows up as latency. However, the performance of literally every other VM is completely protected and totally unaffected. You can always pull up an individual VM's latency graph in the console just to verify that the rest of your environment is humming along beautifully while your noisy neighbor is just chilling under its protective ceiling.
All right, section 3, common exam traps. Watch out for these gotchas.
Let's talk about 3 massive limitations that are absolute prime real estate for exam trick questions. First up is licensing. Storage QoS is an advanced feature. You absolutely must have an AOS Pro or above license. A standard license just won't cut it. Second, upgrade lockouts. You cannot set or alter Storage QoS while an AOS upgrade is actively rolling. The system intentionally locks these configs down to guarantee cluster stability while the upgrade does its thing. And third, this one is big. You cannot apply QoS throttling to the virtual machine that is actually hosting Prism Central. If you click on the PC host VM, that Set QoS Attributes button is going to be completely grayed out. And that makes sense, right? It's a built-in safeguard because starving your primary management plane of IOPS would be a complete nightmare for cluster administration. Okay, let's do a quick active recall test. Put yourself in this scenario. You need to heavily throttle some low-priority background logging VM. You want to choke its storage access down to the absolute bare minimum possible. What is the lowest numeric value you can actually type into the input type field for that VM's throttled IOPS? Take a quick second to lock in your answer.
Well, if you guessed 100, you hit the nail right on the head. The throttled IOPS value you put in must be strictly greater than 99. Why have a floor at all? It's a hard-coded safety net. It stops you from accidentally putting in an overly aggressive misconfiguration that would just outright crash the application. Operating systems need a tiny baseline of disk access just to breathe. If you drop it below 100 IOPS, you're essentially guaranteeing a system hang or a blue screen. If you try to type in 50, the system just throws an arrow and stops you. Now, the only other accepted input is -1. You use -1 when you want to clear the limit out entirely, basically turning QoS off for that VM, but keeping the configuration space ready if you need it later.
Section 4. Key facts to memorize. Flashcard summary.
If you only take away 4 things from this whole explainer, it's gotta be these. Number 1, Storage QoS requires an AOS Pro license or higher. Number 2, always remember your magic math number. Nutanix calculates throughput using a fixed 32K block size. Number 3, to keep apps from crashing, your IOPS minimum configuration value has to be strictly greater than 99, or just set to -1 if you want to remove it. And finally, number 4, the Prism Central host VM is untouchable. It cannot be throttled under any circumstances. Seriously, take a mental screenshot of this list right now.
To wrap things up today, I want to leave you with something to think about, connecting all this theory back to your actual day job. You know how to throttle a noisy neighbor now, you know the math, and you know the gotchas. But tomorrow, when you log into your own Prism Central, I highly encourage you to poke around your cluster latency charts and look at the IOPS utilization. Ask yourself, how would you proactively identify the actual noisy neighbor VMs hiding in your own environment right now, before they blow up a production application? Passing the exam by mastering the how is great, but mastering the when and the who is what actually makes you an elite infrastructure admin. Thanks so much for joining me for this explainer, and keep exploring your environments.